All right. Hello, everyone. This is video note number 44, solving logs with power and change of base. Before we get started, I kind of want to talk about a couple of things first. Thank you all for your continued commitment to learning in spite of our new normal, which is online learning, and all that you personally might have going on at home. Thank you all for your patience and your flexibility as I also figure out how to serve you as a teacher in this way. And so just want to talk about some data from the first week. We had 98% of y'all that watched the Ed Puzzle video. So thank you for that. 91% of y'all that submitted all of your practice in Google Classroom. 90% of y'all that completed the quizzes with the average score of 81. And so that's just some data on the first week. Hopefully you were still able to learn, which is a goal, but I also want to remain flexible and show compassion and understanding that everyone's situation is different. The most important thing is to continue communication with me through this so that I know whether or not you have an extenuating circumstance. Speaking of, have you filled out the survey? Make sure that you filled out the survey because that is the only way I can communicate with you is through Remind, through these mediums of communication like Google Classroom. So I do want to hear from you, and I want to make sure that you are doing all right and also that you are learning the best that you can. All right. I'm recording this video on Sunday because I want to get it out to everyone on Monday for those who like to start early. I sent this survey out on Saturday, so I completely understand if everyone has not gotten to it yet. As of right now, I have 53 responses out of 99 out of 2 kids. And so just want to talk about some of the data I have right now. First question, one of the questions I asked was, in terms of receiving the content notes, which do you prefer? Because I wanted to consider whether I should do live Zoom video, which is something I'm doing for one of my classes, and I know that some other teachers are doing it. But 90% of y'all said so far that you like the working at your own pace through the Ed Puzzle video notes. And a lot of y'all have said that you like being able to pause and kind of work at your own pace. So as of now, we're going to continue with that. Another question that I had was, I had been doing 2 lessons a week, just to kind of consider the fact that everyone has different stuff going on and don't want to overwhelm y'all with kind of a lot of work, even though in the traditional AB schedule, you either have 2 or 3 lessons. And so 92% of y'all said 2 lessons is appropriate. So we're going to stick with that and keep that going. Another question I just wanted to highlight is I asked a question about Zoom kind of video call office hours where I could answer questions live that y'all have about the practice or about the notes. I think in math particularly this is kind of important because in math, in a class setting, usually you'll be working with one another. You would be answering questions, helping each other out. I'll be walking around as well because math is something where you generally might have more questions or generally you approach problems differently. And so 55% of y'all said yes. The other of y'all said, no, I'm okay just asking questions through Remind. So I'm going to have it just for the half of y'all that do want it. And those of you who said you want to ask questions through Remind, I know I've received a lot of questions through Remind. If you have any questions about a specific problem, you can just take a picture of the problem, send me a message, and I will try to respond via text as soon as I can. So thank you who have already done that. The timing of the Zoom calls, the most popular option was Wednesdays at 2, and so that's what we're going to do. That rhymed. So just moving forward, the Ed Puzzle videos are going to be, the first video is going to be due by Tuesday to watch. Second video is going to be due by Friday, so that's a slight change. Instead of following the regular AB schedule, it's just going to be watch the first video by Tuesday, watch the second video by Friday. It will be a completion grade, 100 if you watch both of them, 50 if you watch one of them, 0 if you don't watch any of them. That should be an easy free 100. I'm not trying to make grades too difficult here. Want to make it simple. The 2 practices will be due Friday at 4:20. Some of y'all asked me about missing assignments and redos. If you have any missing assignments from before the break or just ones that you accumulate, make sure that you email or send me a remind individually. The 6 weeks is going to end here in a couple of weeks. I sent the calendar out on Google Classroom. I'll check that out. And Zoom video office hours will begin this Wednesday at 2. So if you foresee yourself having questions, I would encourage you to watch both of the videos before Wednesday at 2 so that you will be able to ask any of the questions that you have from the practice by Wednesday at 2. All right, so usually in class we say our 4 goals, so I'll continue them on here. We will learn math, build character, never give up, and ask why. All right, and we'll go ahead and jump into it. So last week we talked about solving exponential and log. Specifically, we talked about the property of equality, the product property, and the quotient property. We're just going to talk about 2 more today. But first I want to review and make sure you remember how to do the property of equality in exponential and log equations, how to do the product property, and how to do the quotient property. So we're going to do these 4 problems real quick just to make sure that you feel comfortable with them before we move on to a new concept. Or not a new concept, but a new property. All right? So I actually want you to look at this problem, and I want you to solve it yourself, and then pause the video. I'm going to go over the answer after, but I want to make sure that you feel confident, and you also have a way to check that you are correct and that you're solid with last week's topic. So this is kind of be like a DOL for you, I guess. So pause the video, try this problem, all right? Okay, so what you should have done is you should have realized that these bases are not the same, so we want to get the common base. So you should have made the 9 as 3 to the power 2, the 27 as 3 to the power 3, because that's the way you're going to have a common base of 3. This exponent is still there. You're going to keep that up there. This exponent is still there. You're going to keep that up there, and you're going to distribute the exponents. So that'd be 2x minus 2. You're going to keep the base. This one is going to be 3x, right? You're going to keep the base as 3. And you have the equal sign here. And so because the bases are the same, we can see that if the bases are the same and they're equal to each other, then that means these have to be equal to each other, right? And so 3x equals 2x minus 2. That's just a regular linear equation. Just going to move that over, end up with x equals negative 2. And we could check that answer by plugging that negative 2 back in the original equation, but that is what we should have got, okay? All right, the other one was the property of equality. So I want you to take a minute, look at this problem. This was property of equality in logs. So try that problem on your own there. Okay, so we should have noticed that the logs are the same, they are equal, so therefore what is in parentheses have to be equal. So we're going to rewrite this as x squared minus 6x equals 10 plus 3x. We're going to be solving that for x. So because it is quadratic here, we're going to need to move this over all to one side. It's going to be minus 9x. Let me move the 10 over as well, just at the same time so I don't run out of space here. Okay. Then we have this, which is quadratic, so we need to factor. So I'm going to put this over here. A times c at the top, b at the bottom. Our a is 1. 1 times our c of negative 10 is negative 10. Our b is negative 9. That's going to go at the bottom. We're looking for what 2 numbers multiply to negative 10 and add up to negative 9. So negative 10 and 1. Then you divide by the a is 1. It's going to stay the same. So it's going to be x minus 10 and x plus 1. When we solve them, they end up with x equals 10 and x equals negative 1, right? And then what we always want to do at the end is we always want to plug it in to see if it's true or false, which you can either do if you have an Inspire downloaded. You could do that in there, or you could do it by hand, whichever you prefer. But what you want to end up with, the biggest thing I just want to talk about here is some of you were sending me a message on Remind saying, because the x is negative, does that automatically mean that the answer is false? And the answer is no. It's only if when you plug it in, what you have in parentheses is negative. So here's what I mean. Let's say we plug in negative 1 for x. Okay, here, here, and here. So we put negative 1, negative 1, negative 1. And we kind of work this out. Just going to rewrite everything else. So I plugged in negative 1. And let's just simplify this. Negative 1 squared is 1. That multiplies to 6. Log out here. That multiplies to negative 3. Got the 10 I'm going to bring down. And the log base 2 I'm going to bring down. 6 plus 1 is 7 here. Still got the log. 10 plus 3 is 7. Still got the log. And this is true, right? Log base 2 of 7 is equal to log base 2 of 7. That is true. So this is actually true. And when you plug in 10, it would also be true. So you're going to have two answers here. The only way you know it's going to be false is, let's say when we plugged in, we end up with like log base 2 of negative 17 or something like that. And what's in parentheses is negative there. That's going to be false because 2 to the power of no number is going to equal a negative, okay? All right, two more. Just review from last week's lesson. I want you to look at this problem, pause the video, solve it yourself. I want to make sure you feel 100% comfortable. All right, so what we should have seen is that you have a plus, so we're using the product property plus with two logs, which means we're multiplying. This is going to be log base 8, x minus 6 times x plus 6 equals 2. What we should see is we need to FOIL this or box method. So that's x squared, x times 6, 6x, negative 6 times x, negative 6x, negative 6 times negative 6, or sorry, negative 6 times 6, negative 36. So that's what's going to happen when we FOIL that. We're going to have a log base 8 out here and a 2 we're going to bring down. When we combine this right here, 6x and 6x, that's going to be 0. 6x minus 6x. So that's gone, right? So really, let's erase that. What we have left is this. X squared minus, this is a minus from this, 36. And so at this stage, what we want to do is rewrite it in exponential to solve so we can get rid of the log. So 8 to the power 2 equals that, right? And we can go ahead and deal with this. 8 squared, that's 64, right? Now, when you look here, you do see a quadratic, right? This x squared right here. So you could solve this one of two ways. We could factor, which many of y'all may have done, or you could solve it kind of by moving the 36. And either way would give you the right answer. And I just want to clarify both ways. So one way would be to move the 36. So let's say you decided to, I added 36. And I'm going to get x squared equals 100. And then you're like, to get rid of the square, I'm going to square root it. If you do that method, that's fine. You just have to remember that over here you have plus or minus. So you're going to have plus or minus 100, or 10, I'm sorry. Square root of 100 is 10, okay? If you did it the other way, which is I want to factor because I see it's quadratic, you would be moving the 64 over here. You would get 0 equals x squared minus 100. And when you factor, you'll get x plus 10 and x minus 10, because in this case, you have negative 100 at the top, and you have 0 at the bottom. So the two numbers are 10 and negative 10. So you're still going to end up with negative 10 and 10, right? But when you plug it in, I ran out of space, but just when you plug it in, this negative 10 is actually going to be false. So 10 would be your only true answer there, okay? So last piece here is a quotient property of review, and then I'm going to go ahead and talk about today's lesson. So go ahead and pause the video, try this one. So what you should end up with is, because it's minus, you should remember that means you're dividing. So it's log 5 over 2x equals 1. So the minus tells us we're using the quotient property. Then we're going to rewrite that in exponential. The base here is 10. So 10 to the power 1 equals 5 over 2x. 10 to the power 1 is just 10 equals 5 over 2x. We're going to get rid of the fraction so we can just see it more easily. Multiply by 2x. So it's going to be 20x equals 5. And then you just divide by 20. So x equals 5 over 20, which simplifies to 1 over 4. Right? And when you plug that in, that would be true. Okay, beautiful. So that's just a review of those properties. Hopefully that was helpful for you to just kind of revisit that and also see the answers worked out in case if you messed up anywhere. What I want to talk about today is the other two properties. So this, again, is on your formula sheet. Product property. We talked about that right now in last. Quotient property. Talked about that right now. So the other two left are these two, the power and the change of base. So I want to start with power, and I'm going to talk about change of base. And these are kind of quicker. All right. So if you look at the actual kind of formula there, power property, what you see here is you see a log with the base, b, then you see an exponent, okay? Which is why it's called power property. And it's saying that that's equal to this. All it really means is that if you have an exponent here, okay, the power, that exponent can be written out front and be put as a coefficient. That's all that basically states. So I'll say that again. Power property is just stating if you have an exponent, you can put that exponent of the log in front and it will be a coefficient, okay? So why does that work? Let's say I have this right here, log base 2 of 4 squared. I can use the power property and move this exponent in front and get 2. That's by moving that in front. Log base 2 of 4. So we got rid of the exponent by moving it out front, according to the power property. And let's say we wanted to simplify that. Log base 2 of 4, I could find what that equals by putting in the calculator, or I could actually do the math. Log base 2 of 4, what does that equal? Right, you just rewrite it. 2 to the power what? Is 4. And it's 2 to the power 2, right? So x is 2. So this is 2. You can put that in the calculator. You can just rewrite. And then you have this 2 out here. So then it's going to equal 4, right? Now, let's say that you didn't use the power property. You didn't put that out front, okay? If you didn't do that, you could square this here. And you can get 4 squared, which is 16. And bring down the log. And let's say I want to see what this equals. And here I could put this in the calculator. Or I could say, okay, this equals what? 2 to the power of what is 16. And 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that's 4 2's. So it's 2 to the power of 4. And so you see you're going to get the same thing. And so it works either way. It works if you move this to the front, or if it works if you square it at the beginning. So that's why this property works. It equals the same thing either way, whether you put the exponent in the front or you deal with the exponent at the beginning. But what we'll see is in some cases it's better to put it in the front, okay? So let's look at an example. We're going to do these 3. So it says rewrite using the power property, simplify if possible, okay? So looking at this, this is where a power property would be easier. We don't want to do 16 to the power of 7. That would be 16 times 16 times 16 times 16 times 16, 7 times, right? That'll take too long. So instead, I can just say, okay, this is an exponent. I can use the power property, move that 7 in front. So it'd be 7 times log base 4 of 16. And then what I can do is I can now just deal with this, log base 4 of 16. I can think, okay, 4 to the power of what number is 16? And that would be 2, or I could put this in the calculator. Either way, that's going to be 2. And then you get 7 times 2, which is 14. So that'll make it a lot easier to use the power property and bring that out front, okay? Now, or you could put, let's say you have it out front, you could also rewrite that coefficient as an exponent and just write it as log base 2 of x to the power 7. That is also fine, and you can't do anything more with that, but you could rewrite it by putting it out front, okay? Here would be an example in which that would be helpful. Now, we see an addition sign here. Because we see an addition sign there, that means we're going to be using the product property at some point. But one thing to note here, you cannot multiply this times this to start off with because we have this coefficient here. That's important. You have to deal with this first. So the power property will allow you to take this, put it as an exponent. So it'd be log base 5 of 2 squared. And then now, these are now completely the same with no coefficients. So now you could use the product property. So let's simplify this first, actually. So this is 4. So you have log base 5 of 4 plus log base 5 of x. So because the bases are the same in its addition, we can use the product property. and we'll get log base 5, and we're going to multiply these. It'd be 4x. And that's all we could do with that, but that's simplified. So we took these two and kind of simplified them as much as possible. That one used both the power and the product property. The beauty of Edpuzzle, you can pause and rewind. So if it lost you at any point, you can pause and rewind there, okay? So let's do some problems where you could solve using the power property. So let's say we wanted to solve this one, okay? We see we have a common base. We see there's an equal sign. That tells us we would be using the property of equality. But before we do that, we can't go ahead and set this equal to this yet because we have a coefficient out front, right? So the power property will allow us, okay, let's deal with this. Let's just move this up here as an exponent, right? And then now that we have this exponent, we can find what that's equal to. 4 times 4 times 4, which is 64, right? Just going to bring that down. Then, now that these bases are the same, we can use the property of equality. This has to equal this. And then you just solve that for A. Normal equation, add 8, 4A equals 72. Divide by 4. And so that's going to give you your answer there. 72 divided by 4. 18. Okay? All right. So that's how you use the power property. So I actually want to try a few more. Let's try one more together, and then I want you to actually try on your own. So let's say you wanted to solve this for x. Again, when I have a coefficient here, so I can deal with that before I deal with the minus. So I'm just going to move this to the exponent. That power property says we can do that. So we're going to have log of x squared minus log of 4 equals 2. Now, because we have this minus here, we're now using the quotient property, which tells us we're dividing when there's subtraction. This is going to be log of x squared over 4. This is putting together what we learned last week, right? Then, because we have it as written as a quotient, we can make this the base of 10, right? If there's no base, it's 10 if it's log. Rewrite it in exponential. So 10 squared equals that. 10 squared is going to be 100. Move this over here. 100 equals x squared over 4. Get rid of the fraction. Times 4. 400 equals x squared. Then to solve for x, to get rid of the square, we're going to square root. That's going to give us, again, plus or minus the square root of 400, which is 20. So x equals plus or minus 20. So you have to check, is it 20 or negative 20? By plugging it back in, and negative 20 will be false, 20 will be true, so 20 is the answer there. So that's how we're using the power property within using quotient property, okay? All right, I want you to go ahead and try this one. Try this one. All right, so what you should end up with is you should have moved this up to the exponent using the power property. Then you should have noticed, okay, I can use the property of equality because these bases are the same. So I can go ahead and set this equal to each other. And then you could just think, okay, what number to the power of 3 is 8? And that would be 2. So x is 2. Because if you put 2 there, 2 to the power of 3 is 8. And so that's how we get that. Okay? All right, try one more with the power property, then we'll talk about change of base. If you can't read this, I'm going to rewrite it. It says 2 log of x minus 3 log of y plus log of z. So try that one. All right, so that one is actually involves all the properties, right? So let's deal with power first. So we're going to put this one as an exponent. So it'll be log x squared. We'll put this one as an exponent. log y cubed. No, that's a z. Don't judge my handwriting. Okay, now then, you see how we have a parentheses here? That means we have to do that first. Because you have a plus, that's product property, which says we're going to multiply those. So it's log of y cubed times z. Okay, that's dealing with this first because it's in parentheses. Then we're going to bring this down. All right, minus is quotient property. So we're going to divide those since they have the same base. So it would be log of x squared over y cubed z. That one is going to be 1. That one's a little bit tricky. That involved all the properties, okay? All right, so we have talked about product property and quotient property last week. Right now we talked about power property, which just states if we have an exponent, we can move that to the front. Or if we have it in the front, we can move it as the exponent. Last one I want to talk about is change of base, okay? Change of base. So change of base basically states if your base is something, in this case A, you can change the base using this formula to whatever base you want it to be, okay? So let's say we wanted to solve this. We have the base of 2. Log base 2 of 8. What does that equal? We could put that in the calculator. You could just think about 2 to the power what? 2 to the power what? Equals 8. And then we would know it's 3, right? So this equals 3. Okay? So let's say we wanted to change that base for whatever reason. Instead of 2, we wanted to make it, say, 5. Okay? Then we'll be using this formula to change it. So what we have, I'm going to write this bigger, actually. So what we have, this we'll call A. What's in parentheses? The number in parentheses we're going to say is n. I'm just following this. And so if we want to rewrite that, is going to be, now I'm looking at this, log b is whatever base I want to make it. So let's say I want to make the base 5. I need to make it on the top and the bottom. I'm just choosing 5. Now this, what goes here at the top, is our n, which is 8. Right? What goes here at the bottom is our a, which is 2 according to this. And this right here, we now change the base. It was 2, now it's 5. If you put that in the calculator, log base 5 of 8 divided by log base 5 of 2, it is going to equal, I did it already, 3. That's from the calculator, just took a screenshot. So it's going to be the same thing, right? Because we got 3 originally, but if I change the base from 2 to 5, it also gave me 3. Okay? That's changing the base. There's not really a lot of cases in which you need to change the base. There's just a couple. I'll show you when in a second, but let's just try another one. Let's say I want to make the base 100. Just make sure you got that. You can pause the video if you want and try to make that base 100, see what it would look like. You should end up with log 100. Log 100. That's just following this. I'm changing the b to 100. N goes here. N is what? N is 8. A goes here. A is 2. If you put this in the calculator, it will equal 3. And I did that already. And I put that in, and it gave me 3. That's a screenshot from the calculator. You could change the base to 1 million, and it would also equal 3. Okay? Why? We'll talk about that in a second. Let's try these real quick first, though. So let's rewrite this as a single log and solve. So let's say we want to rewrite that, okay, as a single log. And this will be a case in which changing the base would be easier, okay? Because if you try to find log base 6 of 8 by itself, it's going to be a decimal. If you try to find log base 6 of 2 by itself, it's also going to be a decimal. So it's easier to change that base to something that is going to give you a whole number. And so we're going to work backwards, right? So let's say we have n now. It's the top here. We have a. A is this. So it's going to be log. A is 2. N is 8. And log base 2 of 8 is 3. So if we were to put this in the calculator, it would give us 3. But if we change the base, we can do it without the calculator, and it will equal 3. Okay? Let's try one more. This one right here. Okay, it's just using the formula, just label, right? So this at the top is n, according to this. This at the bottom is a, according to this. So it's just going to be, if we're rewriting it in this form, log, the a is 10. This n is right here, 100, and log base 10 of 100 is 2, because 10 to the power 2 is 100, right? This would be one in which you could solve without changing the base, by the way, because at the top log base 10 of 100 is 2, and then log of 10 is 1. 2 divided by 1 would give you 2, right? Okay. All right, last one. So let's say you wanted to solve this for x, okay? We would need to change the base, or use change the base, sorry. So this one, let me erase this. So we're looking over here, the n is this, it's n. A is this, that's a. So if we want to rewrite it into this form, it will be log base a, which is 2, n, which is x. So log base 2 of x, we just rewrote this. That equals 3. And so when we rewrite it, it would just be 2 to the power 3 equals x. And so x equals 8. So therefore, 8 will be the number that if you plug it in for x, would make that true. And that would just be some example in which change of base would be helpful to solve. Usually the product and quotient and power are going to be the most applicable generally, but change of base might come up sometimes, so I thought I'd show it to you. All right, so in closing, just want to show you why that works. Just mathematically, why does that work? Kind of where does that come from, this change of base? Why can I make the base 1,000,000 and it still works, okay? Here's the kind of the why here, but just to show you if you're curious. So let's say you had a to the power x equals n. That's a true statement, right? A to the power x. That's just a general exponential form. Let's say that I just put a log on both sides. Log base b of a to the power x equals log base b of n. According to the property of equality, that works. I did a log on both sides, so therefore what's in parentheses has to equal each other. And what's in parentheses here is this. So that's true. That's okay. Right? And then let's say we're like, okay, let's use the power property. I don't want this exponent here. I want to move this out front. X log base b of a equals log base b of n. Okay? And then let's say, okay, I want to solve for x. So I want to get x by itself. So we're going to divide by this because it's being multiplied. So you're going to get x equals log base b of n over log base b of a. Oh, look at that. That's the formula. That's it. That's where it comes from. If you didn't get that, that's okay. If you did, it's kind of cool. It's okay. It's not necessary. You don't have to know where it comes from. But